In the name of God, welcome to Fairkhaz website. My name is Masoud. I'm a physics teacher. We are here to explain physics curriculum, grade 12 for you. Right now, I'm gonna explain new subject for you in this lesson. Let's get started. The subject is angular acceleration. What's angular acceleration actually? More or less, you are familiar with acceleration. I'm not talking about the angular acceleration right now. I'm gonna talk about the acceleration in general. Acceleration means change in velocity, change in speed. And change does not mean increasing velocity forever. Sometimes change in velocity means decreasing the velocity, decreasing the speed, right? So in both situations, whether the velocity, let's say, is increasing or decreasing, in both situations we have acceleration. Keep in mind that acceleration means change in velocity, whether the change is increasing or decreasing, whether the object speeds up or slows down, does not matter, right? So we have acceleration in general. But right now I'm gonna explain new subject, which is uh, angular acceleration. It's different from actually in general. It's the acceleration in general. It's a general concept. Acceleration means change in velocity. We apply the same concept here, but here acceleration that is dedicated in rotational motion is called, let's say, angular acceleration. Let me read the definition for you, and after that, I'll discuss it with you. Let's say by doing some simple experiments for you right now here. Let me read the definition. The time rate of change of angular speed. So it's the time rate. Time rate of what? Time rate of change of angular speed. Time rate of change of angular speed expressed in radians per second. Instead of actually using radians per second, you can say radian per second square. Radian per second square. So that's the definition. The time rate of change. You see, change of angular speed. I told you in an introduction, I told you change in speed in physics means acceleration. But if the speed is angular speed, omega, so the change in omega in a specific time interval means acceleration. So alpha, from now alpha is the first letter of Greek alphabet. Alpha is used for what? For denoting angular acceleration. And the unit of angular acceleration, you can take it from the rule. Omega is measured in rad per second, right? Divided by delta t in second, rad per second becomes rad per second square. This is the unit of angular acceleration. Let me do some simple experiment for you. And I'm gonna, let's say, ask you some questions about these experiments. This is Earth, for example. This is Earth, right? Imagine the Earth stops right now. Imagine. This is an imaginary experiment. Right now, what's the omega initial for Earth? Initial, let's say, angular speed for Earth is 0, right? Omega I is equal to 0. Let me write it here. So the first situation, omega I is equal to 0. Whenever the Earth rotates, right? What does it take actually? It picks up velocity. Velocity, let's say, increases. For example, omega f becomes 2 rad per second. So the Earth globe, let's say, and I can say it's not imaginary because I'm talking about this object. I'm not talking about the real Earth. I'm talking about the Earth, this, let's say, Earth globe. So in this situation, the object is accelerating. the object picks up angular acceleration because it changes its angular speed. So this is about the, for example, speeding up, right? Speeding up. So does acceleration mean only speeding up or not? No. In physics, I told you, even slowing down means acceleration. For example, the Earth globe right now rotates, right? It rotates. Right now, it has a particular angular speed right now. But if I stop it with my finger, I stop it. What happens to the angular speed? What happens to the initial angular speed? Initial angular speed actually decreases to what? Decreases to zero. And eventually, actually, the object stops. So in the other case, omega I, Earth globe had a certain value, omega I, maybe had 5 rad per second, but eventually I told you it stops. Omega f becomes zero. Final angular speed becomes zero. In both situations, we say that the object is accelerating. The object picks up angular acceleration. One more example, right? One more example. Think about this pinwheel, right? This pinwheel, right now, it stops. So omega I becomes zero. What do you say about this situation? So it picks up acceleration. Why do you say this? Because angular speed is increasing. So does angular acceleration mean speeding up only? No. For example, this is the initial case. The object rotates, right? And after that, I stop it with my hand. I stop it. I grab a blade of it and I stop it. So what happens to the, let's say, final speed, let's say, angular speed? Initial, let's say, angular speed had a certain value, and after a while, whenever you grab the blade of the pinwheel, it stops from motion, and the object stops. The object decreasing its velocity, and we can say it's accelerating as well. So acceleration means changing velocity, and it involves increasing and decreasing velocity as well. Right? What do you say about this example? Can I say in this situation, the object accelerating? The object is accelerating right now? Yes, because it starts from zero. Right now, the velocity is zero. Omega I becomes zero. When let's say, I circle it, right? What happens to the velocity of the ball? It's increasing. That's why it picks up angular acceleration. That's it. So we have a lot of examples. Even in our daily life, we have a lot of examples. If you think about the examples, actually, this is in general. Actually, this is my explanation for angular acceleration. We have some, let's say, notes here, and I wrote the rule mathematically for you. Mathematically, alpha is found by this equation. Alpha is equal to delta omega over delta t. Delta means change in any value, yeah? Means final value minus initial value divided by delta t. The unit of alpha is rad per second square. I told you. Any change in angular speed, increasing or decreasing, I explained it for you, gives rise to what? Gives rise to angular acceleration. Whether the object is accelerating, or let's say whether the object is decreasing or increasing its velocity, means speeding up or slowing down, means it picks up angular acceleration. There are some questions. Let's solve these questions. Let's discuss these questions together. Variation. Number one, variation of angular speed leads to what? Variation means change, right? Change delta. And delta omega leads to what? Leads to angular displacement. I don't think so, right? B, angular acceleration, till now it's true. C, variable angular displacement. It doesn't, let's say, make sense. Variable angular acceleration, no. So only angular acceleration. Change in angular speed means angular acceleration. That's it. Right? Number two, angular acceleration or alpha is measured in. What's the unit of angular acceleration? Rad per second square. Till now is true. Rad per second is not true because it's the unit of omega. Rev per second is the unit of omega as well. B and C, actually B and C are the unit of angular speed, not angular acceleration. So the answer is this one. A is true. That's all, guys, for today. I appreciate you for watching this video, and see you next lecture.